Which kind of arrangement is shown in the left side diagram? Yes, it's a simple cubic arrangement. 8 atoms are there at corner. If you neatly note, you will find gap is there between those 8 atoms, and that shape of the gap is represented in a right side diagram. Actually, it is a void, but in that void, if you have to place atom will be spherical. So such atom will be suitable who can occupy the space properly. So what will be the coordination number for the atom which will go in that void? 8. What is coordination number? Number of surrounding atoms around that central atom. So coordination number for that void will be 8. And that void is at center of the cube. So it completely belongs to the cube. So total contribution, if you see, of the void, 1. So this void is called as cubic void. Coordination number is 8. Now let us discuss octahedral void. But before that, let you know what exactly octahedral structure means. See, left side where 3D model is represented. Here what are you finding? Total 6 atoms are there which are surrounding central atom. So can you imagine a square and above the square one atom, you can say apex, and below the square other atom, that is what lowex. This is the one way by which we can understand octahedral structure. Other way, similar structure only, just I tilted that octahedral structure. Still you can find square is there at center, one point is there above and one point is there below. Same structure, how can you imagine? Just see a triangle. All faces are triangular, no? So one of the triangle, let us consider. And exactly opposite triangle, which is in staggered to the previous triangle. So two triangles which are opposite to each other, such faces are there. Total how many triangles are there? 8. 8 faces are there, therefore the name octahedral. So you have to imagine this octahedral as a combination of triangular faces. And if apex of one triangle is upside, opposite triangle apex will be downside. So in this way, you can understand octahedral structure. Now let us see how octahedral voids are possible in our crystal arrangements. Now see the arrangement of yellow atoms. In which manner they are arranged? Yes, they are in face-centered cubic arrangement. See, at each corner there is yellow atom, and at center of each face there is yellow atom. But between these yellow atoms there are gaps, and those gaps are filled by pink atoms. So what are the types of gaps that we have to find out? Take a pink atom which is at exactly center of the cube. What will you find? It is closely surrounded by further 6 yellow atoms. How are those yellow atoms located? See, 4 are there in square plane. Those 4 are at center of face. They are in horizontal plane. And one point is there in upper face. Similarly, other atom is there at lower face. So square 1 up x and 1 low x. Total 6 atoms are surrounding to that pink central atom. So pink atom is occupying a space, occupying a gap. That gap is called as octahedral void. If you note it clearly, that pink atom is exactly at the center of the cube. So it has no contribution from other cubes, is completely belonging to that cube. So what is its contribution to this unit cell, face-centered cubic cell? Contribution is 1. Now let us see other kind of the pink atoms. Now choose any one pink atom which I had represented here in left side edge. So if you see that pink atom, from that unit cell, it is surrounded by how many yellow atoms? One above atom is there at corner, one below is there at other corner, one is there at center of the face but which is away from us, one is there at right side which is center of the face which is towards us. Now one more that we need to imagine, because it is a continuous building, no? So cubes will be there, such unit cells will be there to left, right, up, down direction. So if you consider one more such FCC cell, then from that pink pointing towards us, there is one yellow atom. It is shown by different color. Why for? Because it is belonging to other unit cell, but certainly it is surrounding that pink atom. Now one more last atom is left, which is extremely left side to the pink atom, which also is belonging toward the other cell. What do you think that yellow atom will occupy which position? Yes, center of face of other cube. Yes, now pay attention towards that the pink atom again. So that pink atom is surrounded by how many yellow atoms which are neighboring to it, which are closest neighbor for that pink atom? 6 atoms are there. Out of them, 4 are at center of faces of different cubes maybe, of different unit cells maybe, and one is there above which is at corner of the cube, and one is there below which is at corner of the cube. Means actually it is also the same octahedral arrangement as I discussed for central pink atom. So that pink atom also can be considered as which void or which gap or which space? Octahedral void. Now this pink atom which is at center of the edge can be shared by how many cubes that we have discussed in the previous part? Edge can be shared by 4 different cubes. So if 4 cubes are sharing that pink atom, then what will be the share of that pink atom to the cube, to the unit cell that we have considered, that is under our consideration? 1 upon 4. Okay, so one pink atom means 1/4 gap. Such how many pink atoms are there? Pink atom is situated at center of the edge. How many edges are there for one cube? 12 edges are there. So each pink atom means 1 upon 4. So such 12 means 1 upon 4 into 12. So how many voids such pink atoms can contribute? 1 upon 4 into 12 is equal to 3. And one more was there at center. So total number of voids from volume point of view will be 4. 1 at center, and remaining 3 are due to 12 voids existing at center of the edge. So in FCC, total number of voids means total volume occupied by that voids is equivalent to 4 atoms. Now, additional logic. In FCC, total number of atoms are 4, and total number of voids present from volume point of view are 4. So number of octahedral voids is equal to number of atoms present in FCC. So if n is the number of atoms present in FCC, then n will be the number for octahedral void. It is a logic. Remember it, that we are comparing when we will discuss other voids. Where are these octahedral voids located in FCC? One position is center of that face-centered cubic arrangement, and other kind of position center of each edge, provided atoms are there at corners and atoms are there at center of faces. Now let us discuss tetrahedral void. On diagram is represented. See, FCC diagram is represented. In this diagram, black rigid atoms are there which are at corners and at center of the each face. Now just imagine a black atom at the upper left corner, number 1. Atom at center of upper face, number 2. The atom at center of the face towards us, number 3. The atom at center of the face but perpendicular to the face pointing towards us. That is atom number 4. If you note it carefully, you will feel its a shape as pyramid, and at center of that pyramid or samosa there is a gap, and that gap is called as tetrahedral void, because that gap is surrounded by 4 atoms. Now such how many gaps are there? Before that, what is the quality of that gap? What do you think? This gap is within the cube, within the unit cell, or at the edge, or at the corner, or center of the face? No, it is within the cube. So, what is the contribution of the cube to that gap? Complete contribution. Or if any atom remains present in that gap, it will completely belong to cube. It is one site. It is called as tetrahedral site or tetrahedral void. Now come to the second diagram, right side diagram. This tetrahedral void, exactly opposite there is one tetrahedral void along body diagonal. Body diagonal means I have to consider that vertex or corner, draw the line up to center, extend the line to same extent, you will find other vertex or corner. Those two vertices are along body diagonal. Now total how many vertices are there? How many corners are there? 8. So how many pairs will be there? 4 pairs. And on each diagonal there are 2 tetrahedral sides. So total number of tetrahedral sides or tetrahedral voids will be 8, and each is within the cube. So total volume occupied by them will be 8. So what we can say in whole number 8. Total number of atoms in FCC 4. Total number of octahedral voids 4. Total number of tetrahedral voids 8. So what is the relationship between octahedral void and tetrahedral void? Tetrahedral voids are double than that of the octahedral voids. So in conclusion, tetrahedral voids are located along body diagonal, and total how many are there? 8. If you see that diagram clearly, 4 you will find in upper space and 4 are there below. So their arrangement also try to remember, because in future when we will study the structures of the various solids, we are going to put the different atoms that tetrahedral voids. So what are the tetrahedral sides? Along body diagonal, and distance also see represented there. From the left face, the distance of the octahedral voids is a by 4, and from right side also, from right side face distance is a by 4, and between two voids distance is a by 2. What is a? A is the unit cell parameter. It is the length of the cube. And what about the octahedral voids? Where are they located? They are located at center of edges and at center of the FCC. So students, let us discuss one rule which decides the number of ions who can surround other kind of ion. That is called as coordination number. Their sizes or radius of ion matters. So let us see in the next part radius ratio rule.